For the second portion of this chapter, we're going to look at various functional groups that are found in your organic molecules. Functional groups are when you take your basic carbon-hydrogen skeleton and you put in an element other than carbon or hydrogen. So when they have something other than carbon or hydrogen, it's called a heteroatom. And that can be anything from sulfur to oxygen to nitrogen to phosphorus. There's just a whole variety of heteroatoms that you'll commonly find. A functional group is a combination of atoms that behave as a unit, and they're distinguished by the heteroatom they contain and how it's connected. So here are a list of our groups, including the functional groups. So we've already gone over alkanes, alkenes, and alkynes, and phenyl groups or aromatic groups, which are this top row here. They're all carbons and hydrogens. They don't have any heteroatoms. It just has to do with how they're connected. But beyond that, we have our heteroatoms present. So if we have an alkyl halide, they're going to have a halogen in them, something from group 7. So that's fluorine, chlorine, bromine, or iodine. Amines have a nitrogen coming off of them, and alcohols have an OH coming off of them. An ether has an oxygen sandwiched between two carbons. An aldehyde has a carbon on the end of a chain that has a double bond to an O and a single bond to a hydrogen. A ketone is a carbon in the middle of the chain, so it's got carbons on either side of it, but a double bond O coming off of it. So those two are very similar, aldehyde and ketone. The only difference is whether it's an internal C double bond O or one on the edge of a molecule at a last carbon. Carboxylic acids are similar to aldehydes, except instead of having just an H connected to the carbon, you have an OH connected to the carbon, and they actually behave very differently chemically. Esters are similar to your ethers, except they have a double bond O coming off one of their carbons. And then an amide is like an ester, except instead of having the OC, they have an NH2 coming off of them. So those are your overview of functional groups. Now we're going to talk about some of them in a little more detail. So first we're going to start with the three groups, alcohols, phenols, and ethers. Alcohols have an OH group connected to one of their carbons. The simplest alcohol is methanol. That's wood alcohol. It's obtained from wood, and occasionally you'll find people drinking it thinking all alcohols are drinking alcohol, and they're not. And unfortunately, methanol causes blindness, and if you have too much of it, it actually kills you. It's used to make formaldehyde, which is used to embalm dead people, acetic acid, and used to make plastics. So it has uses, but drinking it is not one of them. The alcohol we do drink is ethanol, and it's produced by fermenting various things, either grains or fruit juice generally. If you have proof 200, that means you've got 100% ethanol, nothing else present. Not the safest thing to be drinking. It would actually shut your throat. But the way proof is given is you have the percentage of alcohol. If you were to take that proof and divide by 2, it tells you the percentage. So 200 divided by 2 gives you 100% alcohol. So if I had a 24 proof alcohol, that would be a 12% alcohol. And that's actually the percentage of alcohol that yeast cells would actually die at. Once you've got to that, it's beyond what they can live at. It's a waste product of the microbes that we put into these things to produce the alcohol. But eventually it gets so concentrated that they can't survive in it. Isopropyl alcohol is a topical disinfectant. You put it on cuts and things like that to disinfect them. And it has 3 carbons in it, with the alcohol coming off the center carbon. Your phenols are similar to alcohols, but they come off of a benzene ring, off of an aromatic ring. And because they come off that ring, they actually behave very differently chemically. So they call them phenols as opposed to alcohols. They make amazing acids. They can lose their hydrogen really well because of the sharing of electrons taking place there. And it was one of the first antiseptics that they used in medicine. But unfortunately, it damages healthy tissues. So now we have better phenols than just the basic one that have side chains that make them less lethal to the tissue that they're exposed to. Ethers have a carbon with an oxygen connected to another carbon. They're similar to alcohols in that they have the oxygen there, but they don't have the hydrogen. Instead, they have another carbon. Because they don't have that other hydrogen there, they don't do hydrogen bonding, and so they're going to behave very differently than your alcohols. They're generally nonpolar, not very soluble in water because they can't hydrogen bond. They have lower boiling points because the molecular attractions tend to be dipole-dipole or induced dipole, so London or van der Waals interactions. Diethyl ether is your fairly simple ether. It has 2 carbons off to either side. And it was the first anesthesia. And sometimes they would give people too much of it. Do you know those cloths over people's mouths? They're often ethers that they're giving them. And the patients would overdose and things would shut down too much and they'd die. We use more predictable chemicals to do that now, fortunately, and so you're less likely to die from anesthesia, but there's still a chance there, which is why they have one of the highest costs for their insurance if you're an anesthesiologist. Amines and alkaloids are similar. They both contain nitrogen. Amines contain nitrogen coming off a carbon. Their boiling points are higher than alkanes and lower than alcohols. That's because they can hydrogen bond, generally not as well as an alcohol, but they can still do it, and so they'll have those higher boiling points. Their low formula mass makes it so that the nitrogen is the main thing your nose interacts with. It makes them smell really nasty. It's the smell of rotting flesh. So if you get fish and you smell it, generally people don't like that smell. That's amines breaking down that you're smelling. Fresh fish shouldn't have a lot of smell to it. Your amines are bases. They accept hydrogen to become ammonium salts, which make them more soluble in water. Alkaloids are a related class. They are naturally occurring and they're bases because they contain the nitrogen and they often have medicinal value. An example of an alkaloid is caffeine. As salts, they're called tannins. And these are an area of molecules that are researched a lot to see what medicinal properties they have. So if we find a new plant, we'll often look at all the alkaloids and see what they're doing for the plant, that sort of thing. Carbonyl compounds have C double bond O. That's what a carbonyl group is. And different things can be connecting to that carbon that comes off of the C double bond O because that carbon has 2 more bonds. A ketone will have carbons coming off that carbon on either side. Acetone is probably the most well-known ketone. It's your generic fingernail polish remover. Aldehydes have 1 carbon on one side or more carbons, but at least 1 connected to one side usually, and they have hydrogen on the other side. Now there is one aldehyde that just has hydrogen on both sides. That's formaldehyde. It's used in embalming. It's actually responsible for the headaches that people get after drinking alcohol because our bodies take the ethanol and we turn it into formaldehyde, and our bodies don't like formaldehyde all that well. And so we get headaches. The aldehyde can also smell really pleasant. The larger ones often do. So for example, your lemon smell, cinnamon, almonds, these are all aldehydes. So they have these really pleasant smells that we tend to like. Amides have your double bond to your O coming off a carbon, but then they're connected to a nitrogen. So an amide will be C double bond O and then off the carbon NH2 or something like that. DEET for repelling mosquitoes is an amide. Carboxylic acids have that carbon double bonded to an O, and instead of having the nitrogen like an amide, it's going to have an OH coming off of it. One of those you might be familiar with is acetic acid. It's the 5% solution. It's vinegar. Formic acid, this is your ant sting from your fire ants. Propionic acid, butyric acid, that's the rancid butter that you get. And those are your four smallest of the carboxylic acids. Esters have one carbon coming off the carbonyl and one bond to an O that's then connected to a carbon instead of to a hydrogen. And so you get C double bond O, O, C, something else. They're not acidic because they don't have the hydrogen to lose that your carboxylic acids have. Instead, that's a carbon. But you'll find that a lot of your esters are your good flavors and odors, things like banana, just really pleasant things. Esters are a lot of your flavorings in foods.